Hello, this is Jacob Rauer reporting for Dennis, Zandra, and Jacob's Geometry Midterm Review Group. I'm here to present Chapter 3. The first lesson is parallel lines, transversals, and skew lines. Parallel lines do not intersect and are coplanar, and a transversal is a line that runs through a set of parallel lines. Skew lines are also lines that do not intersect, much like parallel lines, but they are not coplanar, so that they're not in the same plane, unlike the parallel lines. Angles and parallel lines. When a pair of parallel lines is cut by a transversal, a lot of angles are made, and these angles have special properties. One type of angle is the purple angles you see here, indicated by the arrows, and these are called alternate interior angles, and they are congruent. The next is the yellow ones, and these yellow angles here are alternate exterior angles, and they're also congruent. And again, this is only if two parallel lines are cut by a transversal. These red arrows pointing to the angles here, they're pointing to the consecutive interior angles, and those angles are supplementary. And lastly, the blue here, these are corresponding angles, and they're also congruent. Next is equations of lines. There are two types of forms of equations of lines. There's slope-intercept form, and then there's point-slope form. In this case, m is equal to slope, and b is equal to the y-intercept. In slope-intercept form, you write it like y is equal to mx plus b. An example would be y is equal to the slope would be 3 times x plus 8 which would be the y-intercept. Point-slope form is y minus y1 is equal to m times x minus x1. An example of that would be y minus 5, which is one of the coordinates, is equal to negative 2, which would be the slope, times x minus 3, which is another coordinate. Distance between the point and the line. This is the hardest lesson in the chapter, and in order to do it, you have to do several steps. First step is to draw a graph, like I did here, and after you draw the graph, you're supposed to draw a line connecting line L, in this case, to the point, which is P. And once you've done that, then what you're going to do is you're going to find the equations of both the lines in slope-intercept form, as you can see here indicated by the y equals mx plus b. Once you found both equations, you're gonna solve for b for both of them, and you're gonna find the y-intercepts of both. And once you've done that, you can solve the system of equations for y to find out where the lines intersect, and that will be point A. And so once you found y, you're going to plug y back into the equation for line M in order to find x. After you've done that, then you're going to have the set of coordinates for point A, and you're going to be able to solve the problem using the distance formula for points P and A. This is just a sample problem for the distance formula. You would find the distance from point P to line L, and L, the points would be negative 5, 3, and 4, negative 6, and point P would be located at 2, 4. So first thing you're going to do is find the equation of line L, and you know the slope is negative 1 by using the slope equation and finding the slope of line L. And once you know that, then you're going to plug in a pair of coordinates, and then you're going to solve for b, which in this case is negative 2. After you've done that, you're going to then do the equation of line M, and that's going to be y is equal to 1 in this case, because that's the negative reciprocal of the slope of line L, plus times x plus b, and then you're going to plug in the pair of coordinates. And once you've done that, you're going to solve for b again, and this time you're going to get b equals 2. So after you've done this, now you found out the equations of both lines L and line M. And what you're going to do is you're going to solve the system of equations for y using substitution. You're going to have y is equal to negative x minus 2 plus y is equal to x plus 2. And then once you simplify that, you're going to get 2y is equal to 0. And that's going to simplify again to y is equal to 0. After you've done that, you're going to plug y back into the line M equation and solve for x. So you're going to get 0 is equal to x plus 2, and then x is equal to negative 2. After you've done this, use the distance formula to solve the equation finally. So you're going to have d is equal to the square root of negative 2 minus 2 squared plus 0 minus 4 squared. And you're going to finally simplify to d is equal to the square root of 32, which is going to be the answer to your question.